In last lecture we have derived Lagrangian equations of motion for the central force field, and we have also derived the angular momentum or the initial position displacement vector, and also the derivation for the energy conservation from those Lagrangian equations of motion. So the first Lagrangian equation was mr double dot minus mr theta dot square plus dv by dr is equal to 0, and derivative of d by dt of mr square theta dot is equal to 0. So this was the second Lagrangian equation, and we have also seen that this term is constant as its derivative is 0, and we have derived this term as L, which is a angular momentum. Okay, now we want to derive the equation of the orbit. Now why we need to derive the equation of the orbit? Suppose this is a center of the central force field, and it is the potential field of that central force field. We know that the central force field is a force in which the potential is a function of only distance. It is independent of theta and phi, which we have seen in the introduction of the central force field. Now suppose if there is any another particle coming into its in this central force field, so that is following some orbital motion. It may follow the circular path, it may follow the elliptical path, or it may follow the hyperbolic path or parabolic path. Okay, so whatever particle is coming into this, so it will follow the orbital path. Therefore we want to derive the equation of the orbit in a central force field. So for that, what you have to do, you just have to put the value of r as 1 upon u. So this u is any function which is inversely proportional to this r. Okay, so just put the value of this r into these two equations. Okay, if I have this r is equal to 1 upon u, r dot will be minus 1 upon u square, then du upon dt. Okay, and what will be the r double dot, or I just want to convert it into the d theta, so I can write it as du upon d theta into d theta upon dt. Now this term is nothing but the theta dot. These are just some mathematical steps to attain the equation of the orbit. So this d theta upon dt is nothing but theta dot into du upon d theta. So this is the value of this r dot. Now if I want to write down r double dot, I have to take the derivation of this r dot. So this is d by dt of this whole term minus 1 upon u square theta dot du upon d theta. So I can also write this or I can just put the value of this theta dot as, see here, so I'll write it here, theta dot is equal to L upon mr square. From this equation I will call it as equation number 3. So from equation 3 we can write theta dot is equal to L upon mr square, and we know that the value of r square we have put it as a 1 upon u square, so it will be Lu square upon m. Okay, so just put the value of this Lu square upon m into this equation. So what I'm going to get is 1 upon u square Lu square upon m, so this is value of theta dot, into du upon d theta, which is nothing but, so this u square and u square will get cancelled, minus L by m du by d theta. So this is the value of r dot. Now let me take the derivative of this, so that I will get r double dot. Let us take the derivation of this term and not this term. So I'll write here r double dot is equal to, so minus L upon m into, or let us go by steps. Okay, Don't skip anything in this classical mechanics. Okay, so you will be definitely wrong somewhere. So this is minus L by m into du by d theta. Okay, so this minus L by m, these terms are constant, into d by dt of du by d theta, which I can write as, I just have to multiply by d theta in the numerator and denominator. So L by m into d theta upon dt into d by d theta of du upon d theta, which is equal to minus L by m, this d theta upon dt is nothing but theta dot, into d square u upon d theta square. Okay, so this again we have to put the value of this theta dot, which we have calculated here. So now I'm writing over here. So this is r double dot, which is equal to minus L by m, value of theta dot is L u square upon m into d square u upon d theta square. So this will become minus L square u square upon m square into d square u upon d theta square. Now let us give the equation number this as a 4, which we have calculated value of r dot, and this as a equation 5. And now let us put the value of this 4 and 5 into the Lagrangian equation, and this will become the equation of the orbit. Okay, just now let us just put the value of this 5 and 4 into equation 1. So m, value of r double dot is minus L square u square upon m square d square u upon d theta square, minus m, r is nothing but 1 upon u, so I'll write it here as m upon u, and theta dot square, again just put the value of this theta dot square, which is L square u raised to 4 upon m square, okay, plus dv by dr is equal to 0. Let us solve this. So this square and this m will get cancelled, and what are the remaining terms over here? So here it is L square u square upon m d square u upon d theta square, minus m, here also this m and this square will get cancelled, so it will be L square u raised to 3 upon m plus dv by dr is equal to 0. I can take some terms common from this, so I can take L square u square upon m common from this. If I take minus term common, I can write it here d square u upon d theta square plus u plus dv by dr is equal to 0. Now we know that this dv by dr is nothing but the central force potential or the potential energy, and we can write it as v is equal to minus integration of f of r dr. So if I take the derivation of dv by dr will be equal to minus f of r, it will be minus f of 1 upon u. Okay, so just put the value of this dv by dr as minus f of 1 upon u over here. So the equation will become minus L square u square upon m into d square u upon d theta square plus u. So it will be minus f of u here 1 upon u is equal to 0, or I can write it as f of 1 upon u is equal to, so let me take this term on the right hand side, so it will become m upon L square u square into d square u upon d theta square plus u. So let me just take whether I have missed anything or whether I have missed any step. So L square u square upon m, so t square, so this is the whole bracket, is equal to f of 1 upon u. So this is minus over here still. We have just taken this f of u on the right hand side. Okay. And f of u is equal to, yes, see here, I have missed something. So f of u is equal to, so this will remain as it is. That's why I keep on saying that don't miss any step. So it will become L square u square upon m. Okay, so this is nothing but the equation of the orbit for the central force field. Okay, and now this equation of the orbit, which we are going to use in many places to calculate the equation of the ellipse or the equation of the circle. Okay, so this was all about the equation of the orbit. So it is necessary to derive the equation of the orbit in the central force field, because whichever parting is entering into the central force field, it will follow some orbital path. Okay, and this equation we are going to use in further equations.